Good evening, everyone. Hope I'm audible to you all. Okay, thank you. Thank you, everyone. So let me try to give you a small brush up on what we did in the week 1, and probably later we'll start with the coding part, right? So let me share my screen with you now. Yes, so this is the screen. In our previous class, okay, so assuming that many of you were starting from the like first time, so you could have installed Visual Studio Code or the Kaggle or Google Colab, or even if you're trying to use Jupyter Notebook. So what you can do here is you can actually pip install the necessary libraries such as pandas, NumPy, Matplotlib, Seaborn, and scikit-learn. Now, as much as possible that we are not going for the visualization part. Anyway, you can do that. But however, we are going to install the pandas, NumPy, and scikit-learn. Okay, so these are the important libraries. So once you are done with the libraries, we need to import these libraries, right? I already told you that. So collection of functions, right? Methods. So that will become a module. A module collection of module is a library. So we have to import the necessary libraries such as pandas. So pandas is used for data manipulation. NumPy is used for linear algebra, I'd say like matrices, arrays. So whatever the calculation that we want to the Python to do, it converts that into arrays of numbers. So numbers usually should be between 0 and 1, or otherwise, the calculation, the usage of resources would be really high. So that's the very reason we do a step called as normalization or standardization. Okay. In order to handle that, we have NumPy. And from multi-output, we have the multi-output regressor. So this is basically a wrapper. And from ensemble method, we are trying to go for random forest regressor. So next, from the model selection, we are taking train test split. And most importantly, the metrics we are taking mean squared error, R square score, right? So though we write it as R2, you have to pronounce this as R square. Okay, so kindly be careful, especially when you're having a conversation with any of the people who have worked on with this. So I'm going to run this. When I run, so you might have seen that it has come 1. So before that, it was a star here within the square braces. And if you look at the Python kernel, now it is idle. If it is grayish or black, means it is running. Okay, so you need to know that. Now I have already given you the CSV file, the data set. So we are going to load the data set. So our data set looks like this. So there are two things, right? Structured data and unstructured data. So structured data are the ones which can be expressed in terms of columns and rows, right? So unstructured are those ones which are like text, images, videos, audios. Okay, so here we are taking a data frame and series. So there are two different things that you need to know. A series is a single dimension. On the other hand, data frame is actually the one which is 2 dimensions. So in the 2 dimensions, what we can have here is we can have the number of rows and the columns over here, right? So as you can see, we have the columns as ID, date, ammonium, right? So bot file, suspended, and so on. So this I have explained, and I have already given you what do you call screen is not visible. Screen is not visible for others. Can anyone help me out with this? Is my screen visible to you all? So someone said it's not visible to them. Okay, it is visible. Okay, so just one kindly make sure that you log out and try to log in. Okay, yeah. So we have a bunch of columns here, and you know that. So it starts from ID. When we talk about ID, like often what happens is that we may neglect this, but when I went through the entire project, then I got to know how important the ID is, because this ID talks about the station ID, which I'll tell you in a moment, and date is very important, and so on. Okay, so next is if I want to know about the information, so I'm going to use dataframe.info. I'm going to run this. To run any cell, you're going to hold on to shift and press enter, right? So information such as like what kind of a data type they are, so it's going to mention that. And when you look at this date is an object, and I don't think that's a good idea, right? So date has to be in datetime format. So that is one thing that we need to understand. And shape is where you will get to know how many number of rows and columns are there. So we have 2861 and 11 columns. And next, we want to know the statistics, means mean, median, mode, and maximum value, minimum value, right? So those are the statistics. And as you can see here, a lot of values are there. And and to know the missing values, we're going to use isnull. Now you might say like, sir, isnull is more than sufficient. So when I run this, as you all can see here, wherever there is no missing value, it's going to give us a Boolean output such as false. So but looking at this, I might not get an idea about it. So that is the very reason I'm going to use a sum function here. So when I use a sum function, what happens is that it is going to just go through all those particular rows and gets us, right, with respect to the columns, it gets us how many values have been missing. So like in ammonium, we have 3 missing values, bot 5 we have 1 missing value, so on. Okay, and to convert this into datetime, as I told you, right? So we are going to use the df of date, and we are going to convert that into datetime. So I'm going to use a method like to datetime. And what you need to pass here is first parameter that you need to pass the column name, right? So and next what is the order that you want to have. Okay, so you can do that. Now some of you might ask me like, so year is coming first, you gave it last. No, the format I'm specifying is I want to have the date, month, and the year. That's it. Okay, so you can there are other types of formats, like you can stick onto that one, so you can give that too. Next is, again, when we come here, like as you all can see, instead of having object, the data type has converted to date time. So next is I want to sort the values with respect to ID and date. So I'm going to go with respect to ID, like all the IDs has to be like increasing way, right? Same as date, as you can see here, 2000 and 2001 here. Now, if I want to separate the date time, especially with respect to year and month, maybe you could do some kind of visualization for that too. So I'm leaving that part to you. So I'm going to run this. And when I run this, as you can see here, I have created year. Now you might ask me, how did you create this? So whenever you want to create a column or you want to call a column, this is the particular syntax that you need to use. Data frame of year. Now, if you want to have y as capital, you can change this over here. Okay, so change that and df of date. And now we have the method here, right? So where we're going to use dt.year, right? To the libraries we have to download in VSC. The libraries I have already mentioned at the top. Okay, so see these libraries: pandas, numpy, matplot, and so on. Okay, so kindly download that. That will be sufficient. Okay, so where was I? Yeah, so guys, kindly ask the questions at the last. Okay, so it will be very helpful to us. And similarly for months, I'm creating a new column here, df dot of month, and it will try to specify us, right? So what month it is. Of course, you have to map it if you want to run it. Next is df of column. So I took the columns. Only the column names will be there. Okay, so like ID, date, and all. Now we want to have some target here. So target means the one which basically does not depend. Okay, so there are variables called as dependent variables and independent variables, right? So we want to separate them out. Now I want to have the target based on these, that is O2, NO3, NO2, right? Sulfate and till chloride I want to have. So that is the reason why I'm just making them as pollutants. So once this is done, I can actually run this. And so this is the object, or I can say variable, that is holding these things, right? Yeah, the notebook will be shared to you in the GitHub, so don't worry about that. So let us start with this week. Okay, so I'm going to mention this as week 2. I'll say like week 2, right? So today is June 23rd, sorry, 23rd June 2025. Okay, so now from here, let us start from here. So that is week 2. So in the week 2, we will try to see there are some missing values here, as we all saw, right? Where was that? So I don't want these missing values, so I can drop them off. So in order to drop something, you need to be very careful. So I'll say like drop the missing values. Okay, so how can we drop it? So we're going to use a method called as drop na method. Okay, so try to use this drop na method. Now df is equal to, df is data frame is equal to df dot drop na. Now when you use drop na method, so this is going to go for the entire way of looking into all the things, right? Like say ID, date, ammonia, and so on. So I don't need that kind of a thing to be happening. I want those values which are present in the target, which I have done here, like pollutants, to be taken care of. So what I'll do here is that I'm going to use a parameter called as subset. So if anybody has any doubt, you can just press on shift and tab here. Okay, so when you press shift tab, so it will let you know a kind of a documentation that you can see here. So df.drop_na method is like first, so you can give any number of arguments here, right? So star axis 0 means rows, 1 means columns. Okay, so subset is here. See, looking at the index of the label. So there are a lot of things you can run into those parameters, what they are trying to explain. Okay, so you can go around with it. It's kind of huge, and also they will give you some examples here. Also, see, as you can see here, df.drop_na subset name and toy. So based on that, we are going to drop it like that. So kindly go through these things. You will be able to understand that. Okay, so here I'm going to say subsets is equal to pollutants. Okay, so let me call this. So the whatever the missing values were there, so it has been cleared. So I think we can say df dot isnull dot dot sum, as you can see here. So based on O2 till Cl, we have removed it, right? So all those values have been removed. So we did not touch about the ammonium, we did not touch about the suspended. Okay, so this is what I wanted to tell you about the subset. Okay, so now let us do feature selection. So here we're going to call this as feature and target selection and target selection. So as I told you, what do you mean by a feature? So feature means independent, independent variables, and target means dependent variables. Okay, so I guess independent is E. So these are the two things that we are going to differentiate. Now, how can you do this in machine learning? So I'm going to use capital X, where this is for feature. Okay, so we want to select the features. So I'm going to say df of, we can take. Okay, so now when we are taking the data frame of multiple columns, so we want to specify it as a 2-dimension, right? So what we'll try to do here is I'll try to say ID and also based on the year. So this will be the feature. Now what will be the target? So target will be the one where I'm going to use pollutants. I'm going to use the pollutants. Now be careful how I'm doing. Look at this. When we are using the specified column name, I'm using 2 square braces here, but here I'm not going to use that. Supposedly, if this were to be a column like this, then I might have done that. Okay, so be careful about those. So now let us run this, and we'll do something called as encoding. So I want to specify something to you, encoding. So encoding means here that we are basically trying to give some value. Okay, so say like for example, we can use something called as one hot encoder. So when you use one hot encoder, what it basically tries to do is that let us say we have 22 stations, right? So wherever the station is number 1, so it is going to specify 1. Okay, so this will be done for all the 22 stations. That means to say it will say 1 at one particular column, and rest of these stations it will become 0. Okay, so again when it comes for the second station, it will say 1 there, and first one until the last it will become 0. Okay, so this is one hot encoding. So this basically is used for the machine learning to understand, to grab the what do you say, the numbers, right? So whatever the features were there which were containing non-numbers to numbers between zeros and ones. So this is what it's going to do. So here I'm going to say x encoded. Okay, if you use label, say for example, if I say like first station is Delhi, second station is say Mumbai, third station is Bangalore, something like that, machine learning will not understand the words Delhi, Mumbai. So what we'll do here is that instead of doing that, we will say Delhi is 1, Mumbai is 2, Bangalore is 3. So what happened was, whatever the categorical variable were there, like Delhi, Mumbai, Bangalore, has been changed to 1, 2, 3. So this is pretty easy for the machine learning to work. Okay, so now let us do the encoding. So I'm going to say like x encoded, where I'm taking the feature and I want to encode that. So I'll try to take pd dot, how is the syntax? So you're going to call the pandas and you will say get dummies. Okay, so get dummies is a function that we are going to use. And here I'm going to use the feature first, and I want to specify the columns. So column here, I'm going to take ID. Okay. And since we are doing this, we know something. Okay, let me explain that in the later clay. So I'm going to use drop first is equal to true here. Okay, so now when we run this, the encoding is done based on the IDs. Now let us try to train, test, and split it. So let us do that. Train, test, and split. Now I'm going to use, I'll explain this. Let me write down the syntax first. Xtrain, comma, xtest, ytrain, comma, ytest is equal to train test split. Okay, so this is a function which we called right through the pre-processing. So we're gonna open the parenthesis there. We have to mention. So I'm going to say I want to have x encoded here. Okay, so I'm going to take that, and I want to mention y here, and next I want to mention test size. So test size, I'll keep this as 0.2, and last but not least, random state, I'm going to fix it. Now the most important thing that you need to understand here is that what we're going to do here, whenever we get a data set, okay, so we are going to split the data set into just a second, let me, where is my epic pen? Yeah, I'm going to write that on the screen so that you'll be able to understand. Yes, let me take this. So whenever you have a data set, okay, so we have a data set which is nothing but 100% of data, right? Now what we'll try to do here is, we are going to split this data. How do I split it? I'm going to split, it's not visible. Roshan, kindly log out and log in, because most of the students are able to see the screen. Kindly do that. So we're going to split this into train and test cases. So that means to say here, so we'll use this universal value, that is 80% will be used for training and 20% will be used for the testing case. Okay, so say for example, we want to give, we want to train you. So what I'll do here is that when I want to train you, means I want to make you to learn a new subject. So I'll explain all the things to you in the class. And lastly, before we are going to end the class, say I'll give you a small question or a homework. So work on this one. So like that. So here I have taught you all the important things. Here there is a small thing that you need to understand, like how did this thing happen? So in order to do the homework, you should have attended the class. Just like that, you will have the 80% of the data which will be used for the training cases and 20% of the data which will be used for the testing cases. And based on this test, you will get to know how well your model is performing. Is my model really good or it is really bad? Is it, is it only learning the training? That means we're going to call this as overfitting problem, right? So it's just like memorizing. Say for example, some students, okay, so they have memorized everything that I have taught in the class. Instead of learning, they just memorized it. But when I give them the homework, they cannot do it because they have memorized it, just like that. So this problem is called as overfitting problem. And that is the very reason what we need to do here is that we need to train this. And remember, the model has not seen test data set here. It has not seen that. So I'm going to train it and test it. Now what we have here is that we have two things. One is feature, the other one is target. So feature is given by capital X, target is given by small letter y. You can change it, no issues with it. Okay, so don't worry about it. So for training, you have X train and X test, right? Similarly, Y train, Y test. Next, we're going to use train test split, as I already told you. So this parameters, what it takes usually is, first one, it is going to take the feature. And next, it is going to take the target. And next, usually, it will be the test size. Okay. And next, lastly, it will be the random state. Now, what is feature here? The feature means the column that is, I mean, the set of columns that is very important for us. Here, it is X encoded. We have encoded, remember that, ID and date. Next is target. So target means this Y, okay, dependent variable. Next is test size. So as I already told you, what is the size of the test here? 20%. 20% is nothing but 0.2, right? So that is the test size. So next one is very important thing, which is called as the random state. Now, what is this random state? Now, first, let me tell you, how do we split this 100% into 80% and 20%? Can anyone tell me? How do we split 80% and 20% of training data set from 100%? Say, for example, some of us will say, sir, we will take ID from 1 to 80, like we have 100 data. Okay, so 100 values we have. So we will take 1 to 80, and from 80 to 100 will be the test. Okay, this is one scenario. There will be another scenario where some of us want to take the IDs 1, 5, 10, 15 in terms like multiples of 5, right? And there are chances that we can do this in permutation and combination. You can do it in very way. So that is a random choices can happen. So in order to fixate how splitting is done, we're going to use something called as random state. We're going to use the random state. So that means to say this random is used for splitting? No. This random state and data set splitting are entirely different. Be careful. Do not try to confuse with it. So say, for example, my computer, I want it to be split from 1 to 80 for training cases and 80 to 100 for testing case. So this splitting, when it happens, I'm going to assume a state value. I'm going to assume a state value as 1. So that means to say, if anybody is using 1 as a random state, this is how the splitting can happen. Okay, if someone is used 42, however the splitting has happened, so that is going to be there. So just when you try to look, want to do it in the, your PCs or local PCs, change this. You can give any number you want, no issues. So the splitting is going to happen in that particular sense. So don't worry about that. Okay, now I have given 42, try to check with the 42. If you want, give 30. If you want, give 72. If you want your favorite number, if it is 007, try to give that. Okay, 7. So no issues. Okay, so this is regarding a bit of clarification. Okay, regarding it. Let me clear this off. Let me start. Now, when we are done with the random state 42, okay, some of you are giving some answers. Okay, yeah, you can change it to anything you want. 42 has a story, if you know that. So anybody's worked with those things. I mean, like if you have worked as a data scientist, you will know a lot of stories and theories are there when taking the random state as 42. It's not just because of the community. There is a story behind it. Try to follow that up. So let us run this random state. Okay, so train test splitting is also done. Okay, now most important thing, how do we train the model? So training the model is basically dependent on not about the word as train. So here we are going to use function or a method called as fit method. So first and foremost thing, let me say here, train the model. Now here, I'm going to say model is equal to, I'm going to call multi-output regressor class. Now, what are the parameters that you can give? First and foremost thing, I'm going to use a random forest regressor. So since this is the wrapper, I want to take that up, right, within the random forest regressor, and within the random forest regressor, I want to specify how many number of trees that has to be there. So for those of you who do not know what is a random forest and what is decision tree, so imagine like saying like we have, let me take a pen here. So we have a decision tree. Okay, so this decision tree is basically like I want to say like I want to buy a car. Okay, is it yes or no? Okay, so if it is yes, next what is the other thing? If it is no, what is the other thing here? If it is yes, what is the budget? Again, you try to split it and so on. Okay, so this is how the decision tree usually works. I said no because maybe like bus is cheaper, right? Or otherwise I could say like there is not much more distance from my home to my college or something. So there are lots of reasons. So the decision tree is gonna like go on having number of nodes extended up, like we call them as child nodes. So it's gonna go. Now imagine you have like one decision tree here. If you have multiple of them, then it will be called as a random forest. Okay, bunch of trees will form a forest, right? So that is the reason why we're going to use the forest here. Now I need to mention how many number of trees I'm going to use. Like I could say 100, for example, right? I can take that also. So that is what I'm going to do here. So let me clear this off. Now I'm going to come here. So how will I call the trees? I'm going to say n estimators. Okay, so n estimator parameter, the first one, I'm going to say 100. So 100 trace here, and I'm going to use random state. So again, I'm going to fixate onto 42 here. Okay, so this is first how you're developing a model. Now I want to train it. As I already told you, model.fit. Fit means to train. So how we are going to train? So I'm going to take X train and based on Y train. Okay, so what is X train and what is Y train? X is for feature, Y is for target. Remember that. So we are going to train it, shift enter on that, and you will get it like this. So as you all can see here, we took a wrapper. Within the wrapper, we have the random forest regressor there, right? So you can just expand this. You'll get to know, and yeah, Okay, so here it should have shown you a number of estimators, means number of trees actually. Okay, so now let us try to evaluate the model. So how well my model is actually working, right? So we will say evaluate model. And how do we evaluate the model? So I'm going to use something called as ypred here. Okay, so ypred object there, I'm going to call it. I'll say model.predict. Okay, predict is a function. So model.predict. Now, model has already seen X train and Y train. So what it has not seen, okay, under the test cases. So we are going to say capital X test. Okay, so in order, like we are doing the test, so we're going to take X test here. So try to run that and you're not going to see any answers because it is just getting stored here. Remember that. So what I'll do here is that I'm going to create a function for all the different models that it is going to get created. Okay, so I'm going to say like print. I will say like model performance is enough, right? Model performance on the test data. Okay, so I'll say something like this. And once it is done, I will say, okay. So for, I'm going to use a loop here. So for I and pollutants, for I and pollutant in enumerate. So if anybody knows enumerate, you can say pollutants. Okay, so what happens in the enumerate is it's going to take two things. One is index, the other one will be the name, right? Like you can say index and fruit in fruits, right? Just like that. So I want to print, what I want to print is, I'll take the f string here. So I want to print the pollutant name actually, pollutant. Okay, close this. Remember, whenever you're using f string method, you have to open and close with the curly braces, right? Like this. So the pollutants for those things, I think I'm going to print the, I guess first one, let us take MSC, right? So we will start to, yeah. So MSC, MSC stands for mean squared error, right? So MSC, and I'm going to take the mean squared error function here, and I want to pass in the parameters. How do we calculate the mean squared error? So based on the test and prediction, right? So what is the test here? So I'm going to use y test, and now remember here, I'm going to calculate this for the entire model of one pollutant, remember. So I'm going to use ilog method here. Okay, so integer log of all the rows of the ith term. So say for example here, first one would be oxygen, right? So I can use that. So next one, I'm going to go for y underscore red of all the rows of the ith column. So similarly, I think this would be fine if I just copy down this command V over here. I'm going to use R square method. So R square method is our square score over here, right? Y test of ilog would remain same. And now I want to just, have some space here. So I'm going to give it like this. Now, when I run this, as you all can see here, so model performance, it is there here. For I and pollutant, what is the first pollutant we got? We got the O2. For the first pollutant, it printed that out. I want to have the MSE, mean squared error, and R square, right, over here. So I wanted to look into that. Now, some of you might, okay, someone has already asked. So here, when you want to get to the values of it, like individual rows, okay, let me come here. Now I want to go 0, look at all the values over here. Again, come over here, 1, all the values here. So in order to do that, we are going to use location and integer location there. So sometimes we also call it as index location. So this integer location will go like 0th row, first row, second row, right? It's going to go like that. Similarly, for the ypred, it's going to go with all the rows of the specified column. What is the first specified column? That is O2 here. So it is going to take the mean squared error of the entire O2 over here, and it's going to give out. Now you might say, like, sir, what do you mean by 22.2? Is it percentage? No, 22.2 is not a percentage. MSE means mean squared error. What is the error you have? Now say for example, okay, so I'll give you an example and then I'll move. So say for example, there is a student. Okay, so we're going to call that student as R. So assuming myself. So what happens here is that the teacher will say, okay, Raghunandan will might score in data science. Okay, like he might score 90 marks, right? However, maybe I did not study well, so I scored 80. So here, what is test value? It is 80. What is the predicted value? It was 90. What is the error here? What is the error here? It is 10. 10 marks is the error, right? Like that. But when you're subtracting it with test and the prediction, what will happen? 80 minus 90 is minus 10, right? So we will have that kind of an issue. In order to make this, we're going to use MSE, mean squared error. So that means to say minus 10 square is how much? 100. So it is, the answer is in positive sense, right? Similarly, now why did we go for RMSE? RMSE stands for root of mean square. So what is root of 100? It is nothing but again 10, right? So that these are the things that you need to understand. Similarly, we have MAE. So MAE stands for mean absolute error. So it's just like a magnitude. So magnitude of minus 10, how much is that? It will be plus 10 only, right? Like that. So this is what we're going to use. Okay, so I hope you got an idea. However, when you look into the R2 here, R square here, so this will be the percentage. So this will be nothing but the model performance. This will be the model performance. Now this model performance usually will be in terms of percentage, means you need to multiply it by 100. I guess you will get somewhere around 1.6% minus 1.6%. So this is not a good idea. Means the O2, based on the O2 model, it is not working well. Now look at this one. It went up to 51.6% for NO3, right? So these are all the things that you might see as we move ahead. Okay, so there are lots of things. So it was not able to come to the correct conclusion part. That is the reason why you have negative there. Okay, so these are all the performance, model performance will be there. We use MSc, RMSc and ME. These are called as metrics. Okay, so how well, okay, as I said, like there was a student R, how did he do well in exams, right? How do we measure that? How do we measure that? So we have some metrics here, right? So some people will say CGPA, some people will say percentage, percentile, right? So that will be called as a metric. Okay, so I hope I was able to help you out. Even though ID column is already numerical, what happens here is that it might, 1 to 22 means there will be a lot of resources that might be used. So cut down that. I am just making sure, like some of the students, they would say like, sir, we have, older PCs or something like that. So that is the reason why I have used it. Or otherwise it's okay. If you have good resources, you can just go with it. But ultimately what happens is that your model can balloon up. So kindly be careful and try as much as possible to do the encoding part there. Okay, so where was I? So we got the model here, right? So once the modeling is done, let us try to test it. Okay, so how do we test it? Now here, what I'll do is I have already created a prediction values here. So I'm going to use that. Okay, I'm not going to write it once again. It's kind of huge. So let me use that here. Okay, so here I'm going to say 22. Okay, now let me first explain to you like what I have written here. So first thing is I'm going to take the station ID. So I'm making sure that the user inputs it, right? And what year input you want. Now, what is the year? Can anyone tell me what is the year that we are actually looking into? From 2000 to 2021, right? Our data set is taking the values that we have trained from 2000 to 2021. Yes. Now I want the value. I want to predict the future value. I want to predict it for the year 2022. This is called as prediction. Okay, so I'm going to take the input data. I'm going to create that as a data frame. Now, some of you might ask me like how to create a data frame. It's very easy, pd.data frame, and you have to pass in the dictionary there. How do I pass in dictionary? So I'm going to take the first one, that is key as year, and the value will be the year input value. So here 2022 will sit, and in the ID, so you're gonna mention 22 here. So as far as I know, like when I last checked, like based on the tail function, I got to know it was 22. So if you have any other values, you can mention that, but be careful, it has to be on the same, because we are not using try and except method here. It might give you some different things. So I'm going to take the input where the values, whatever I got for the ID. So station ID 22 will be, it's going to get encoded there. So once encoding is done, so we want to look into the missing columns, like X encoded of columns, and we're going to take that from the input encoded columns. And if there are any missing values, we're going to check it. So for starting, we're assuming that there are no missing values. Okay, so based on that, it's going to work. And next, I'm going to predict it. So how I'm going to predict it? Model.predict function. So predict function I'm going to take, and I'm going to take the input of encoded, whatever the value you gave, like 22 we gave it. So 22, it is going to change it into some ID. So we will take the first value of it, and now it is going to look into the pollutants and the predicted pollutants there, and it will start to print. And we are basically trying to take the 2 decimal places of the values over here. So let us run this, and as you all can see here, so this is the value for the station number 22 in the year 22, sorry, yeah, in the year 2022. So O2 will be 12.6, NO3 will be 6.88, and so on till chloride here. Okay, if you want to change it, say for example, I want to look for 2024, so I can change it and I can run it. So it's going to change the values there. Okay, but it is very good idea that when you want to change the values here, try to change it from, okay, try to reset and run from the top, and next you will change this. Okay, so these are all the values that we started to predict, and it is trying to give based on what it has learned. You might say, sir, this cannot be the value. Yes, maybe it might not be the value, but this is how it has learned from the trained data, right? Whatever the data we had in our hands, based on that we have trained it, and it is predicting the values in the future, right? So next, what I'll do here is that I'm going to export this as a model file. Okay, can't we predict either water is safe or not, sir? You can do it. See, that would be your what do you say, improvisation. You want to do it. Okay, here I'm not doing that because I know a lot of things, especially about the data sets, so I'm restricting at certain cases. However, if you want to do that, you can do it. Just go through the PDF which I have sent you. What is the right values for the safe drinking or not? Try to look at those values, and you can just put a if statement, and you can say like if the value is between these and this, it is safe, or otherwise it is not, right? You can do that. So last thing, let me finish it off. Just wait a second. So we will try to export this. So have I imported the job lib? No. Okay. So what I'll do here is that I'm going to import, okay, job lib here. So this will help me out to save, right? This will help me out to save the model. Now what I'll do here is that job lib dot dump. So it means I'm creating a model, and I want this model. Okay. What is this model? This model is nothing but this one. Okay. The training one. So be careful about that. So model, and I want to name the model. So I think I will say pollution model, right? pollution underscore model dot pkl. So pkl stands for pickle. So we are going to save this as a pickle file. Okay. So once this is done, we are going to save this. And next, I'm going to go for joblib.dump. Yeah, joblib.dump. I'm going to take the x encoded right, dot columns. So how we did those columns, right? So I'm going to use that with the toList function here. So I want to have the same way of doing that. So I'm going to say model underscore columns here dot pkl file. Means if you are going, if anybody is going to do this as say for example, you're going to, like in the next week we'll be doing the model deployment, right? So we need this file as well as this file. Okay, a model as well as the encoded values. So that is what we need. So we do not want our model to be encoding in a different way. We have already done that, right? So this is for only for our confirmation. You can write it or leave it. I'll say model and columns are sorry, column structure, right, are saved. Now let us run this shift return, and it has been saved. How do I know this? I'm going to come here, look at the value. 2 seconds ago it was saved, right? Pollution model.pickle file, model columns.pickle file. So both files have been saved. Now when you look into the model.pickle file, it is almost 32 MB, right? 31.7 MB. It is almost 32 MB. And when you look at the columns, it is only 183 bytes. You might ask me, so what has happened? So how the encoding was done and what are the things that were encoded has been just saved into model.columns. That's it, right? The way how it was done, the structure of it. Other than that, model pickle file is actually where the model is entirely, how do I say, like packaged together. Okay, so this is about, I think I'm going to say like, yeah. So this is about the project for week 2. So what you will do, guys, is today from week 2, right? So we started from here, from the 15th code up to 25. You're going to run it by yourself, save the files, upload that onto your GitHub repository. Once it has been uploaded to your GitHub repository, take the link and you're going to submit it on the LMS. Now, kindly be careful. I mean, please be alert that submission date will be activated probably on Wednesday or after Wednesday. Okay, so kindly have some patience on that. Or otherwise, I will ask them, but still try to have the patience on that. So kindly don't message us and saying like it's not been activated. Okay, so I think I can take some questions here. If anybody has any issues or anything that you want me to repeat, I can do that. Anyone, anything? No, try to create it in the same file. Okay, so try to create it in the same file as I did week 2, week 1, everything is in the same file. Okay, but if you want to say like, if you want to say like, sir, I want to specifically mention how my training went week 1, week 2, week 3, then you can do that. Okay, if you try to directly use the random forest, what will happen here is that random forest regressor uses the single target value, right? Here, when we use, where is that multi-output, this multi-output regressors will try to create multiple models. Like what we did here, we have this, right? O2, N3 till chloride. It will create a new model for O2, new model for NO3, new model for NO2 up to Cl. It's going to create new model. That is the reason why we have the wrapper. And for every wrapper, you need to specify the regressor. So what I did for O2, random forest regressor, NO3, random forest regressor. So I have split it. Okay. And once it is all done, it's going to wrap it. So that is the reason why we're going to use multi-output regressor, not directly. Here, remember one thing, everyone, you might be asked in the interviews or probably when you give the presentation. So here you have multiple target values here. So you do not have a single target, right? Multiple target values are there. That's the reason why we're going to use it. Okay. Yeah, I will give them my GitHub link once I upload it. Okay. You have to have, give me some time. So yeah, so what we did in the week 2 is we basically looked into the missing values and we eliminated all those missing values. And once the missing values were eliminated, we did the feature selection. After the feature selection, we did encoding. After encoding, we used train test split and train the model. Once you get this is training. Okay, the model has been trained. Once the model is trained, obviously, like once you are ready, you will be tested, right? Just like that, we are testing the model and we get a lot of values over here. Remember, MSC is not one which it will talk about the performance. Performance of model is always R square. Okay, so R square score is always the one. So since I told you like multiple target has multiple models. So once we get it, we're trying to test it. Once we get the value, we have just dumped it as a model. With this model can be used by Streamlit, Gradio, or AWS to do the interactive app development. That's it. Okay, so that is a brief summary. Okay, hope you got it. What I told you. Dump is to create a model, right? Model.pickle file was there, right? So that's the reason why we dump it. But when you go for convolution neural networks and all, you can do it as save model also, right? Model.save is equal to .sav or h5 model. There are a lot of .keras, just like that. Get dummies is used for the process where you want to do one hot encoding. So I specifically, tell you all to do a lot of research, especially on this. What do you mean by encoding? What do you mean by one hot encoding? Why do they say one hot encoding? At a time, it can do only one, right? If you have 22 columns, it will take one column and it will say one for that. For the rest of the columns, it will be 0. And when it takes second column, first column will be 0, second column will be 1, the rest columns will be 0 again, like this. And that means it is going to create a lot of columns inside it. So there is a good thing and a bad thing about the get dummies. So I'm running collab. Can I continue week 1? I'll create another. It is not necessary to create create another notebook file. Okay, that is more than sufficient. Okay, so explain last import once. Last import is joblib. So this is a function, I mean, library that we're going to use. Joblib will basically tries to take the model which it has learned, right? From that model, it is going to create a pickle file. Okay, so that is the reason why we use the joblib. When you do, we are not only creating only for the model. If you take only for the model, what happens to the encoded values, right? The same way it has to be encoded. So that is the reason why we also take the columns of the encoded also. So it tries to makes it as a list. That's it, rather than nothing more. Okay, so sir, while coding all things, most of the time I get blank and don't get what to do next. Try to see, one of the ways that you can learn is when, say, for example, you came here, right? So copy this code, put this on your new tab, try to look at, because there are people like in Stack Exchange and other websites, they try to explain it to you, right? So try to do that. So one by one, you're gonna try to understand. Okay, one after the other, you're going to understand. So that would be my thing. Why are you asking greenhouse emission project? This is water prediction. And why did you come here? Like, okay, so I think I have explained how to upload files into GitHub. Okay, see, let me take my Safari here. Just a second. Where is my GitHub? Yes. So this, I think my screen is still shared, right? So this is my GitHub. I'm gonna go for my project here, like June. Where is that? Water quality. So here I'm going to upload it. How do I do that? I'm going to go for add file, click on upload files, click on choose files, and where did we save? Actually, desktop, right? Yeah, desktop, water quality, and as you can see here, we have those files. So click on those files, model, pollution, and water quality prediction. So click on upload. Now, what will happen here is that the previous okay, something is greater than 25 MB. Okay, so that means to say, I'll give you, I mean, we have to upload that as in a Google Drive, and then we can do it, or you have to use a large file system for the GitHub. So anyway, using large file system is a little tricky. What I'll do here is, I think I can take pollution and water quality prediction.ipynb file. I'm going to upload it. I will say week2 code. Yeah. So week2 code completed, right? A simple message like that. Click on commit changes. So when you come here, the water quality, so you have the files except for model, right? So for that model, what I'll do here is that I'll try to create a link and I will post it here in the readme file. Okay, Google Drive link, I'll try to paste it here, so thereby you will be getting everything at your end, right? So I hope Dhruv Tiwari has seen that and others have seen that. If input contains NaN, that means you have not eliminated the missing values. Try to check with that, Priyam Agarwal. So while coding all these things, already explained, so please show us how to upload. I have shown it. Okay, so people, you need to have some kind of patience. Repeating these things will not get you anything. Joblib is where of a library that will help you out to create a model, right? Output of a model will be a pickle file. You can take the pickle file and put that in your Streamlit or Gradio for interactive apps. So your week2 assignment is to upload the same files which I have told you already, right? And take the git link and paste the same git link in your LMS portal. Coming for cell number 24, station ID is 22. So we're going to mention the station ID for those who has doubts. For others who have understood everything, you can leave the class. You're done. Okay, we are done with the class. You can just put the attendance. Kindly make sure that you put the attendance and then you leave. Okay, for those who have issues, I think we have 3 minutes. I'll try to wind it up. So station ID we're going to mention, year input I'm going to mention, right? So once it is done, I need to encode it. So I'm going to encode it based on the station ID. That is 22 has to be encoded. And once it is all been encoded, I want to try to look into whether they have any missing values. If there are any missing values, then we have to sort that out, right? So once it is not there, then it is going to go through the predict function here. So it will start to predict, and I'm going to take the first value of the prediction. So once the first value of prediction is there, and I'm going to take those values, it will try to mention it like this. Oxygen is 12.6, NO3 is 6.8, NO2 is 0.13, like that. Okay, so that's how it's going to be. So the entire model is 25, more than 25 MB, right? 31.7 means more than 25 MB. So we need to upload this into the Google Drive, and then I'll share that Google Drive link probably in the GitHub. Okay, so try to look into that and don't try to ask us again and again. Okay, so I guess that's it then. Thank you, everyone. Okay, someone said explain. Yeah, random state is, say you are splitting some values. Okay, so train test splitting has been done in certain way. Okay, so I want that to be maintained at all the other end. Like say I'm the programmer or I'm the coder. My client also wants to get the same answer. So how the splitting has happened on my PC and how the splitting has to happen in his PC will be fixated onto the value called as a random state. So you're going to use the random state, and here in the random state we can give any value between 0, right, to 1 and so on. So you can give it. Usually what happens is that they will give 42 as an example, 30 as an example, right? You can take the value. So even if you want, you can give 1 also there. Okay, so then I guess that's it. You can upload your pickle file if it is greater than 25 MB, obviously, to Google Drive. I've been explaining again and again and asking the same things. I don't know like how you people achieve that. And then that means no one is listening to the class. I mean, like at least the people, some people. Yes. Okay, 6:30. Okay, guys. Thank you. We'll catch up in the next week. Okay. Bye bye. Improvisation is not mandatory. That is left to you.